then I can do whatever I need to do with them.
Did you get hail the other day?
We did not.
Dang, we got a lots of hail over here. All the trees are stripped.
Wow. Where do you live?
Just kind of by the library. It's
Oh, yeah. No, that was you got that hail, I believe, on the day that we met at that library.
Yeah, I'll send you it on email. I have a
You
picture.
did. You showed it to me as a video when I saw you that first time, and I
Oh
got there
yeah,
about 5 minutes after the hail had ended because I
yeah.
got to that library and I saw all the cars were covered with leaves and stuff.
Yeah, it was pretty bad where I live, and it's just like 5 minutes away. Not even that, but
Right.
yep.
But no, I was glad not to get it.
Oh yeah, I know.
I got a garden I didn't want destroyed
hmm
by hail. So, all right, these are actually some problems that you could have verbalized these. And sometimes there's stuff to be gained by verbalizing it. In other words,
Uh-huh.
you can learn a lot by verbalizing a problem.
Uh-huh.
You don't get a lot of chance to do it. I suspect that it's very
Yeah.
rare where they call you up in front of the class and they have you verbalize a problem.
Mm-hmm.
And so sometimes it's worth verbalizing it just to know how to do it. In other
Mm-hmm.
words, how do you verbalize that answer?
How do I verbalize
Yeah,
it?
verbalize it for me.
Um, oh, 2x in parentheses, 4x plus 5 in parentheses.
Okay.
So,
Or
yeah.
2x times the quantity 4x plus 5. That's another way.
Okay. Okay.
You don't always have to say beginning parentheses, ending parentheses. Although that's
Okay.
actually the most exact way to say it.
Mm-hmm.
Okay. Okay, so that's the greatest common factor. And remember to do one thing as you're taking a greatest common factor. Always. As you're doing it, make sure you're checking to see that that term is the same as that term. In other words, before I even wrote the 5, the moment I wrote 4x, I should be checking to make sure 2x times 4x is 8x.
Yeah. Yeah.
And then when I write the 5, I'm going to check to see if 2x times 5 is 10x.
Uh-huh.
So if I check as I'm doing it, I don't need to check afterwards. In
Okay.
other words, after you get this answer, you know it's good because you were checking along the way.
Mm-hmm.
Okay, let's look at this one.
So that'd be 2 so 2 the quantity of 6y minus 8.
Correct. Okay. Number 3.
She said something about a negative, and you can't do this with a negative or something.
No,
Is
you
that
can.
okay? You can. Okay, I probably just heard it wrong, but it would be
No, there's nothing that keeps you from factoring out a negative. You just have to be a little careful with this second term.
yeah.
And you don't have to factor out a negative. In other words, I could do this problem in a couple of ways. What's the greatest common factor, with or without the negative?
Um, the greatest common factor,
Uh-huh.
15.
15d cubed.
Mm-hmm.
The greatest common factor is the largest entity that will divide into both of these terms evenly.
Mm-hmm.
D cubed divides into d to the 5th evenly, leaves d squared, and it divides into d cubed, it leaves 1.
Yep.
Notice that d to the 4th would not be able to divide into d cubed. So
Okay.
it's not going to be d to the 4th. Okay, so if we assume it's 15, not negative 15, what goes right here?
Um. Uh.
What is this term divided by this term?
So it'd be negative 1d2
That would be it. How about the second term?
plus 3d plus 3.
Just 3.
Would it be just okay?
Okay? And
Okay.
the reason I know is because as I was doing it, I multiplied those two together and I got minus 15d to the 5th, which is this term.
Uh-huh.
And I multiply this times that, and I get plus 45d cubed, which is that term.
Okay.
So that's correct. However, if I choose, I can also take out a minus 15d cubed, and that leaves behind a positive d squared, but then I have to make sure that that's negative.
Okay.
So
Okay.
either one of those is correct, except for maybe the terminology. If you're taking out a greatest common factor, that would imply that it would have to be positive, because 15 is greater than negative 15. So
Okay.
that's perhaps why your teacher said that. She doesn't want you factoring out negative. But you can do it. There's nothing that says, in other words, this is every bit as correct as this.
Yeah, yeah.
It's just maybe doesn't fit the definition of the terminology properly.
Uh-huh.
You could argue that it's not the greatest common factor because minus 15 is smaller than plus 15.
Mhm.
Personally, I like doing it this way better.
Which way?
I like doing it the second way better.
Yeah, yeah, yeah.
I prefer to have my positive number in front of the
Hey.
variable inside the parentheses as opposed
Mhm.
to up here.
Yeah.
This can get people in trouble because they frequently think that that square applies to the negative sign, and it does not.
Okay.
Okay? All right, let's go do more here. And she says, if there is no greatest common factor, say that it's prime, and that's what it would mean.
Yeah.
If there's no greatest common factor, it would have to be prime. Is there a greatest common factor here with 4?
No.
Correct. In other words, that's a prime number right there. So
Mm-hmm.
unless that is a multiple of 13, there's no way you're finding any number that divides into both 20 and 13.
So
So
that's just the answer?
yeah. In other words, the greatest common factor is 1. If I want to
Yeah.
factor anything out, I can factor a 1 out.
Yeah, yeah.
Like the instructions say, if a 1 is the greatest common factor, then that means it's prime. Always, no matter whether it's letters and numbers or whatever.
Okay.
How about 5?
Um, so you do C parentheses, um, or actually it would be negative C.
No? Take out
No?
a positive. Well, let's see what happens. Take out a positive C. What goes here?
Uh, C3.
No. Now, check it real quick. Does that give you the first term?
Yeah.
No, it doesn't. C times C to the third is C to the fourth. Remember,
Okay.
there's an implied 1 right here.
Yeah. Okay.
Okay? So, this can't be C cubed. It's got to be C squared.
Okay.
And check it. C times C squared is C cubed. We're good to go to the next term. What's the next term?
Plus or right. Okay. So it'd be
So
C.
divide that term by C. What's C squared divided by C?
So it'd just be C.
Correct. Now multiply that by that. We get C squared. We're good to go. Now what's the last term?
Um, C or
What would I have to multiply this by in order to get minus C?
just a negative, just
Negative 1.
one. Okay.
And now if I check, that times that is negative C. So
Okay.
all 3 terms are correct. In other words, if you do this final check, multiply all 3 terms. But let's make sure that you know exactly what we're doing here. C cubed divided by C equals C squared. C squared divided by C equals C. And finally, minus c divided by c equals minus 1. That's how I got what was in the parentheses.
Yeah.
And that's what you're doing when you take a greatest common factor out, is you are dividing every term that you see being added or subtracted. You're dividing by that greatest common factor.
Okay. Yeah, I was just confused because I didn't write it down. I need to write it down.
Now, notice if I would have taken a negative c out, that actually does work, but now I got to have that, I got to have this, and I got to have that. In other words, that is the same answer that we just got.
Yeah.
If you multiply it back together again, you'll see it, that it's c cubed plus c squared minus c.
Okay.
But it is not nearly as pretty looking. So I would not take out a negative c here. And if your teacher has specifically instructed you not to take out negatives, then don't do it. I mean, it's one thing to be saying, I'm fine with it, but if she's not, stick by her rules.
Okay. So the greatest would be
first thing, well, yeah. In other words, first thing, check the numbers. Then check the letters.
Yeah.
Okay. Can 6 be divided evenly into all three numbers?
No.
Which one can't it go into?
Well, yeah, I thought you meant the whole 6 and 2. Just 6 can, yeah.
Just 6.
Yeah.
Okay, so far I can take out a 6.
Mm-hmm.
Is there any kind of n that will divide into all three numbers?
No.
No. So that's not part of the greatest common factor.
Mm-hmm.
So what's left when I divide each term by 6? What goes here?
So it'd be one n 2 or
1n squared.
okay.
Always make sure that when you're done.
Okay, yeah, because I'm not dividing it. Okay.
Yeah, just the real quick check so that you will never make a mistake is as you're going, multiply it back together, make sure you get that.
Okay.
6n did not. In other words, if I would have written that, immediately I can see that doesn't work. 6 times 10 is 6n.
Okay.
So that's the way to do these. Okay, what's the rest?
Minus 5n.
Okay.
Plus 40. Plus 7.
That's it, right there.
Okay.
Okay, and all right, we'll just keep doing more of these. I guess we have 8 minutes to go. If you're really comfortable with this, we can go look at the second page. Let me see if I can find some tougher ones here.
Okay.
Number 9.
Number 9? Okay. So, doesn't have a greatest common factor.
A number? Is there a number that divides into both 18 and 50?
Yeah, okay, so...
Has to be because they're both even. So the worst case scenario is 2.
Okay. Yeah, okay, 2.
And 2 is correct. So I could write it like this. This is actually y squared, excuse me. Now, the instructions said factor the greatest common factor out. It didn't say factor the thing. But,
greatest common, okay.
Right, but while we're talking about it, let's talk about fully factoring the thing.
Okay.
What's this called here? Actually has a name. Difference of what?
I'm not sure.
Difference of perfect squares.
Okay.
Why is that called difference of perfect squares? That's a perfect square. It's 3x times 3x. That means the difference. And that's a perfect square. 5y times 5y.
Mm-hmm.
So if I have two perfect squares separated by a negative sign, a subtraction sign, I got the difference of perfect squares. And
Yeah.
what does that mean? Well, if I want to put it more generically, there's the difference of perfect squares. That always factors
Mm-hmm.
into a minus b times a plus b. Okay?
Okay.
So the difference 9x squared minus 25y squared, what would that factor into?
That'd be that'd be 3x minus 3x.
Hold it, 3x minus 5y.
3x minus
Yeah, because A is 3x and B is 5y.
5. Okay.
Times what?
Times 3x minus
Plus 5y. You don't even have to think about the other half. The other half is always the same thing, only with a plus.
Okay.
Okay?
Okay.
So, if the question was fully factor that, well, it would be 2 times 3x minus 5y times 3x plus 5y. The product of those three things.
Okay.
And I'm a little surprised they put it in here like that because she didn't really say fully factor it. She just said factor greatest common factor out. And if the job is to just factor the greatest common factor out, this is the proper answer.
Yeah. Yeah, we were just starting to just because we're doing parabolas, we're just starting to refresh on polynomials.
Uh-huh.
Yeah.
Yeah, no, that's factoring is huge for algebra. You want to make
Uh-huh.
sure you understand greatest common factor. You want to make sure you understand how to factor a quadratic. You want to make sure you know how to do difference of perfect squares. All of them.
Mm-hmm.
All three of them are vital.
Yeah.
Let's do one more. Let's do 11.
Okay. So let's see.
Is there a number that divides into both numbers?
Let me see. 108 divided by no. Or yeah, there is.
What is it?
3.
36.
Mm-hmm.
36 goes into 108 three times.
Yeah.
But let's pretend we didn't know that. In other words, let's pretend we did not have a calculator in front of us and we were able to figure it out. Well, I can see that both numbers are even, so 2 must. But 2 would
Yeah.
leave 18 minus 54. They're still even. I can
Okay.
take
Yeah.
another
That's.
2 out. So it would be 2 times 2 times 9 minus 27. Now I can take a 3 out. So
Mm-hmm.
I could take a 3 out, and that's going to leave 3 minus 9. I can take another 3 out. Well, by the time I've taken each one out, look what I have. 36.
Mm-hmm. Yeah.
In other words, I guess what I'm trying to say is you don't have to be perfect on your first shot.
Uh-huh.
I got away with taking out a 2. As long
Yeah.
as I recognize that I could still pull out more factors out of that.
Yeah. I just keep thinking it's least common, but it's not.
Greatest common factor. It's
Greatest common.
not least common multiple, which is a
Yeah.
similar concept, but it's
Yeah.
greatest common factor. So I'm
Okay.
going to pull out
I
a
just need to get that
36.
to my.
What about the letters? How many R's can I pull out?
Okay. Let me write it down. So wait. So we're just going by 36.
Yeah, in other words, I recognize that 108 is divisible by 36. So I'm going to go ahead and pull the 36 out. So that takes care of the number part. What about the letters? How many R's? There's an R there and an R squared there. I can pull at least one R out.
So yeah, you can pull an R out, and then you can pull an S squared out.
Okay, so that's what I'm pulling out. That's my greatest common factor. What's left behind?
Okay, so it'd be 1 R.
No, not one R. Remember,
Be 1.
notice that if I put an R there, now if I multiply the two of them back together,
Yeah.
I'm going to have an
Okay.
R squared, and there's no R squared there.
It would be a 1S
Nope. It's
minus
just 1.
okay.
In other words, what I'm doing is I'm dividing that term by my greatest common factor. So I'm taking the term that I'm looking at and dividing it by
Yep. You're right.
6RS squared. That's equal to just 1.
Okay.
Okay? What's
Yeah.
the rest of it?
Um.
What do I have to write there such that when I multiply that by whatever I write there is going to equal that?
Yeah, it'd be minus 3 3RS.
Correct. And then real quickly in your head, multiply them back together again. Do you get 108R squared S cubed?
Yep.
You've done it right.
Yep. Okay. Just gotta check.
Yeah, and the easiest way to check is to check on the way.
Okay.
Don't wait until you have the entire answer to check.
Yeah, because you've done
Just
work.
check piece by piece. Well, if you wait until you get the entire answer, well, now you're going to have to multiply both fully to know whether you got it right or not. If you check as you go along, you'll not only get it right more often, but you won't have to do that final check.
Okay.
Okay. All right. We can end it there unless I see something really interesting here.
Oh, but there's like a backside to the just number 2. It's only because isn't number 2 in standard form?
Yeah, but it's not. It's in standard form, and we kind of need it in vertex format, which means we have to complete the square. In other words, if you look at number 3 is in vertex format.
Yeah.
Okay, so number 3 is really easy to figure out where the vertex is, locating point. You know the vertex is at 1, 9.
Yeah.
Okay. Number 2 is not in vertex format. So what the parent function is f of x equal x squared.
Yes.
But in order to figure out the horizontal shift and the vertical shift, we'd really need to put it in vertex format. And in order to put it in vertex format, we need to complete the square.
Yeah.
And have you been taught how to complete the square?
We were doing it like algebraically.
Well, that's the only way to do it. But once you complete the square, then you can make this look like this. Not exactly like that, but it'll be in vertex format.
Yeah, you just have to have the equation, right?
Well, I'll go through it with you if you want, how to complete the square.
Okay.
If you want to take another few minutes, I'm fine with that. So we have f of x equals 1/2 x squared plus x minus 3. And the way I want it to look is like this. Some number times x minus h, quantity squared, plus k. So if I can make this thing look like this thing, then I'll have all the information.
Yeah.
Easier. I guess I need to do that. Because I can't tell what the horizontal shift or the vertical shift is until I put it in this format.
Yeah, that's how we're doing it.
Okay, well, here's how you complete the square. First of all, you kind of isolate those two, factor out the 1/2. Here, you'll see what I mean here in a second. Have I changed anything?
Nope.
It's exactly the same. And that's the key with completing the square. Make sure that every row you write is the same as the previous row. Okay? Now, to complete the square, I'm going to take half of that number and square it. Well, half of 2 is 1. I'm going to square it, and I'm going to add it right there inside the parentheses. Well, I can only do that if I counterbalance it by subtracting a number from the same side of the equation. In other words, I can't just arbitrarily add a 1.
Yeah.
It's now different than the previous line.
Mm-hmm.
But what did I do? I added 1, but I added 1 multiplied by a half. So I really added a half to the equation, which means if I subtract a half from the same side, now it's the same.
Mm-hmm.
Okay?
Okay.
And now I've got it in a form where I can write it in this format. Because when I completed the square, I'm now able to write that as x plus 1 quantity squared. So my thing turns into this. That's the whole reason we completed the square, was so I could write it as a monomial squared. Those two combine to be minus 3.5. Now I know everything I need to know about this thing. I know where the vertex is. The vertex is at minus 1, comma, minus 3.5.
Mm-hmm.
The horizontal shift is 1 unit to the left. The vertical shift is 3.5 units down. In other words, as soon as I have it in vertex format, I can answer all these questions they're asking you.
Yeah.
I can answer the parent function as y equal x squared. Horizontal shift, you can read directly if it's in vertex format. You can read it. Vertical shift, you can read it. Locating a point, the vertex, you can read it. So there's all kinds of advantages to having it in vertex format. But you have to complete the square to do it.
Okay.
Okay? All right. I'll let you go, and I will be with you next week.
Cool. Thank you.
Tuesday, I think, is our session, or is it Monday? Let's see. I think, hold on. Let me just, before you go. Okay, it's Tuesday and Thursdays. Okay. Tuesday at 5:30, Thursday at 4:30.
Okay. Cool.
I'll talk to you Tuesday at 5:30, and I will merely text you the meeting ID number.
Yeah, that's fine. Thank you.
You're welcome.
All right. See ya. Thank you so much.
You're welcome. Bye-bye.
All right. Bye.